So yeah, if I ever would do and or explicitly as like a compound claim that you can agree or disagree on as a whole, because that's essentially what for me it boils down to. I would do it like this. But to come back to the first point, whether or not logic should be modeled as claims or as things building on top of more atomic units, which are just all the pieces of information which are relevant, that's something that I'm still undecided on. Because you could also look at a compound claim as a second layer thing that pretty much adds logic on top of all the other claims that have already been aggregated in more of a lower level model that doesn't contain logic other than these are relevant pieces of information. Does that make sense?
I'm not sure I followed perfectly what you were saying. I apologize. I was still trying to lay out display stuff. But I think what you're saying is you agree with the notion of if we're going to do logic and model compound claims more specifically, you have no objection to this way of doing it as subclass of compound claim. But did I miss something? I think I missed something, pretty sure.
No. So this is how I would do it. But my question is concretely, if you have three claims, it all has to do with curation and community contributions and how to have an aggregate overview of those. Yep. And I think it's isomorphic, so it doesn't really matter. But I very much look at community contributions as, oh, you had one relevant claim, you had one relevant piece of information to the bigger canonical puzzle. Like suppose rather than having a compound claim, which is, let's say, conjunction, where you have one claim and another claim both supporting a conclusion, you can already add these as two separate supports right now, correct? Or you can add a compound claim, and it's more like which one is a canonical form and how do you resolve conflicts?
Okay.
And what I'm somewhat thinking is that a easier canonical form is if you don't model logic. If you do want to model logic, you just model it on top of a easier to agree upon canonical form. Like if somebody adds a compound claim, for example, on the second layer, that just translates to adding two supports.
Okay, I think I understand the question better. And yes, doing it this way, for example, I think we said that the other day, is it does allow less canonicality. Meaning, for example, it doesn't force disjunctive number form. That means, for example, I need to be explicit about, say, associativity. Somebody says, to have conclusion Z, you need A and B, and then somebody adds C, and then somebody starts with B and C and then adds A, and those are the same. Those should be the same canonical claim. So how do you do that? So do you do it with a tree, or do you say A and B is now replaced by ABC triple compound, and so is B and C. The other binary is replaced by ABC triple compound. And then we have this relation, this other relation, which is saying that this triple compound is supposed to be a refinement, or is proposed as a refinement, may be accepted as a refinement of either binary version. And then we have canonicality of the triple, which we don't have if we do it through a binary tree. Binary AST. Does that make sense?
I think either way you can come to a canonical form. I'm not so much concerned with that. It's more of the how you do that, because each time you're going to change and propose new changes, that means everyone that has contributed even a tiny piece to that needs to somehow approve to that. Otherwise, you're going to imply that they agreed with something they never agreed to in the beginning. That's really what because the building blocks become less atomic, it becomes harder to contribute to them and that's why I mean, no, they don't become, It's much easier to say I believe in that claim, I believe in that claim, than to say I believe in this compound form, and then afterwards being notified, hey, but a new claim was added to the compound form. Do you still agree with these, etc.? That's what
that's a very real concern. I totally agree. I think it's on the one hand necessary, on the other hand, it's necessary to provide simplifications and shortcuts, because the maintenance of agreeing with each combination is also prohibitive. You have a point there.
But so why I'm saying it's isomorphic is, of course, if you model it like this, you can still derive, like, whether or not you have a base layer where you don't have the notion of compound claims, or you do have compound claims and you just infer, like, that you, let's say, translate all the compound claims to support form where you don't have that extra information, you can still render that.
The problem is with proofs conclusion. Like, if you have support, right, you can say this supports, and oh, also this one supports, and you can kind of do it independently, and it doesn't matter. But when you say this is a sufficient condition, then you need compounds, because, you know, it's not the same of saying A and B is sufficient versus A, B, C is sufficient.
No, so I would model that as in support of the support, as relevance. So if
I think that's very different.
If you have a claim that you find to be sufficient to prove a conclusion, and in order for that argument to work, that works because there's these other claims underlying it, I typically model it as relevance, which is indeed not true relevance, but it fits the linguistic model of because, which is pretty much
yeah, I'm bothered by that, because this is where you get into non-canonicality, because either of them could be the starting point.
Because isn't a relevance only mechanism.
No, but it's relevant because, sorry, I wasn't complete here.
Yeah.
Like A supports B, which is relevant because.
But this is where I'm saying we do lose canonicality there. If I'm saying A supports B, but you also need C, well, I could also have said C supports B, but you also need A.
Which is canonical, in my opinion. I don't mind that you need, if you can say it in both directions, you can. It's still canonical. It's it reduces the problem to that, as opposed to where, like, which is the correct compound claim among all the different compound claims, and that explodes exponentially.
But also for me, when I say support, it's about supporting. And then you'd need to have a different way of supporting the causality. It is true that A leads to B, which is not the same as saying A and B are both necessary for C to be true. And that's a distinction I want to keep. Sorry, I should say it is. There's a difference between A supports C is also supported by B, because A and B, there's a difference between saying B supports the inference scheme from A to C, which is one thing, and B is a co-necessary condition of A.
Yeah, but you're arguing that you want to model compound claims. You're arguing that you want to model an.
I'm arguing that this distinction matters.
Yeah, but okay, so I'm arguing, yes, I understand that that's a relevant distinction, but you're modeling logic, and I'm saying if that distinction matters, the question is, do we model it in this model, or do we model it referring to something more that doesn't contain richer logic like that?
Right.
That's what I'm wondering, and I haven't made a conclusion. I'm just bringing up that's the only.
And it is a valid question. Yeah.
And again, I think it's isomorphic. If you model it, then you can still infer a translation which doesn't model it. That kind of.
So, let me see if let me boil this down to a concrete example and see if we can think about it from there.
Yeah, just one with 3 claims.
No, that doesn't. Yeah, you're right. Exactly. So Stephen and Marc-Antoine are members of the CDL, right? And so you're going to support it with, well, except the example I want to do is more complicated or is more specific. So let's do Stephen and Donald Trump are members of the CDL, right? So you're going to support it with Stephen is a member of the CDL.
Yeah.
And I guess somebody opposes it with Donald Trump is not a member of the CDL.
Yeah.
Right.
Or somebody
Now,
supports it with Donald Trump is a member of the CDL.
yeah. Now, what I'm concerned about is the roll-up scoring mechanisms, where because if a person simply goes and looks at the top level claim and sees sufficient proof that Stephen is a member of the CDL, but Donald Trump is not a member of the CDL, they can go ahead and say, I believe this claim is false. But if they are debating elsewhere, Stephen is a member of the CDL, and they're debating elsewhere, Donald Trump is not a member of the CDL, what will the automatic scoring of that tell them about their belief in this other claim?
In the
right?
conjunction?
And in the top level, Stephen and Donald Trump are members of the CDL.
But nothing, that's the thing, you don't model it, so it wouldn't automatically allow the user. The thing is with a more basic model where you don't model logic is, that's why I keep saying, for me, it's the user that decides the scoring. It's not an algorithm that I want to automatically run the logic. For me, if the user then, based on that information, he can see that they already agreed Stephen is a member of the CDL, they already disagreed Donald Trump is not a member of the CDL. For me, it doesn't automatically need to bubble down that the user therefore disagrees with Stephen and Donald Trump are not a member of the CDL. If that's something you want to support, that's the so that, then you need to model logic. But I'm saying that's not the primary goal. Because yeah, in some cases-
It's not in scope for you, yeah.
I'm not certain whether it's in scope. So, but that's the what I'm feeling. It's not an immediate necessity because the user will have all information to already see. Well, obviously, I can do an AND operator in my head. I disagree with this claim, and here are all the reasons why. For me, that's more important than automatically applying that logic. Because then the question is, can the user at that point override the decision of the scoring, which all of a sudden becomes more of an engine and less of a claim as the base claim is? That's where my conflict lies.
And when the claims are more complicated, your beliefs could disagree with itself.
Exactly,
right?
exactly. Maybe the and is, oh, but not really in this context. I meant exactly because
right, but and even with the complete proper logic structures, it should be possible to override. I don't see that any conflict in that.
Okay.
The point of
but you should be aware that
showing what somebody should be, yeah, exactly, is to surface internal apparent contradictions, right?
Yeah.
So yeah, my intuition is that I do see use cases that would need us to go that way. You know, a simple one might be, oh, you believe this. Do you also agree with these statements? There's a lot of kind of next step conclusions. Like I could certainly see a lot of higher level interfaces with the system that would like to walk people through conversations like that. If you believe this, do you also believe this?
And by these inconsistencies, learning happens, right? People actually get convinced.
But it would only be the inconsistencies in the logic that you have modeled in a model that you can point out.
Right.
So if you model
and that, you know, that's like the reason score approach to things is, you know, essentially, oh, your side is losing. Are you missing some arguments there? You know, get in and interact with the debate a little more to see what information is missing here. But
so that's also why I think, does it have to be in a base layer? Because you can still model this. You can still model this.
Depends on what we mean by base layer, because I think necessarily you would want the data, which is this, your argument, you want the argument map to be containing this information. In other words, you don't want to have underneath some other structure, because this totally changes the actual structure of the argument map itself. And it's not something you can layer on top unless you're essentially creating your own new copy of the database, right? There's like, for example, let's take the example of referring to external documents. You could picture having the whole database model there, right? The whole argument model there. And then some other system goes and creates connections from those arguments to external documents. That wouldn't require restructuring the underlying argument in order to do that. Whereas essentially with the anything involving scoring and rolling up, that would require you to redefine claims in a new structure that would be impossible to maintain side by side with some lower level map structure.
Yeah, again, I think it depends on what you intend to do with scoring.
I do want to point out that I understand a bit your one thing I do understand is your reticence to require logic, because that is a huge burden. But you know, I wrote in my model that compound claim was abstract. I can certainly see having an making it not abstract and saying we can have a undefined compound claim as a step towards progressive formalization, and say, you know, people will not say whether this is disjunction, conjunction, whatever else, until somebody decides to. And saying the notion of composition is there, because now we kind of need it now that we've received multiple, we've removed multiple premises. And I think that was the right move, by the way. But then we need compounds, I think. And if we need, but what I'm arguing is, do we need to bake logic into the base model? We can have it available in the base model without forcing people to use it. That's all I'm saying.
Yeah. And when I said I think it's isomorphic, I think it is. I mean, if you have a disjunction and you would remove the compound claim, you essentially simply have multiple supports. If you have a conjunction, you essentially would have like for each of the claims a support, and then all the other claims in the conjunction are added as support to the relevance. Then you have all that's you could say how it would be modeled in a more base layer. And then you can just
I don't know if it's isomorphic. There's a loss of information there.
Yeah, it's one way. Sorry, it's what's the name for it, Marc-Antoine? You can do a transformation from compound claims to not having compound claims, which would be the equivalent to what I'm saying would be a base layer. You then attach the, oh, this is actually a compound claim information too. That's what I'm saying.
Morphism.
Yeah.
No?
Yeah. And I did say and that was my original point. I think there are two cases of where between conjunction and supporting the argument that I wouldn't know how to.
No, you wouldn't. It's not represented. It's not represented in the.
Yeah. That's what we mean by. Is there loss of information in the morphism?
Yes, there is. So yeah, you're right about that. But it resolves how you merge all these conflicts of, hey, here's a compound claim, here's another one. Some of them overlap. This is actually one bigger compound claim that should be merged as one. And it resolves that because you simply remove it, because I think my intuition tells me you don't need it to support at least use cases that I envision where people want to be redirected to the correct discussion with the right focus.
Yeah, I hear what you're saying, but okay. When you say there's multiple compound claims, I do see the problem you posed about, do we have to bother people all the time? Do you still believe this version with augmented compound claims? That I do see. But I don't see the problem of confusion between compound claims. Because for me, each compound claim is pretty clear. It may be more or less inclusive, and we may or may not agree that this becomes an additional defeater or an additional necessary condition or an additional this or that, right? But and we should ask ourselves, in which case is it possible to make the maintenance of these compound claims be reducible to UX operation on atomic claims? That is a valid question, and I totally think we should explore it. But I think that when I'm saying, well, here's the 3-member compound claim, and here's the 4-member compound claim, each of them is clear in and of itself.
Yeah.
And we can have a relationship between them, that this is supposed to be, more accurate because it contains more information. That is also clear, and there's no.
Yeah, but that's where you get like a non-canonical form. That's what I'm saying.
No, that's what I'm saying.
My definition.
No, I disagree. I disagree. It's not canonical. That's a claim I'm trying to make.
It depends on what canonical is, right? Because yes, I understand that like that it represents the status quo and you have everything captured, but it removes things you can agree on. And one thing that is essential to structure like disagreement essentially is to find like more atomic things you can agree on. And you don't necessarily need to start agreeing on conjunction and disjunction to start agreeing with the underlying components.
Okay, so that is really the question. Can we reduce agreement on compounds to agreement on atomics? Because that's actually a fascinating question, right? And this is, and I think and I think in many cases you can.
If you agree with the logic.
Exactly. This is actually a use case for doing logic, is that it makes agreeing and disagreeing with compounds reducible in many cases, not in all cases, but in enough cases to make a huge UX difference, reducible to agreeing, disagreeing with atomic components.
But how do you disagree with the logic? So the point is, if you do it in a if you don't have conjunctions, you just have a claim that says A and B, and then you support A and you support B, and the user can see, oh yeah, A and B, yeah, sure, I believe in A and B. If you then don't believe with the logic, you can easily add as an opposing thing, well, this logic is flawed. A and B, no, that's not true because C, whatever, something is omitted. There can be so many reasons that logic is flawed. That's the big open question.
Yeah,
you can model disagreement with logic in the same fashion. You can still open up the discussion to users and aggregate all of these disagreements on whether or not the logic is flawed or not within the same structure that we already have. That's the beauty that I see in that. Whereas if you add a compound claim, all of a sudden, how do you agree with the logic of a compound claim?
But what I'm saying is there are cases where you need to go at the compound claim level, and there are a majority of cases where you don't. So the question is, if you disagree with the compound claim, can I express my disagreement as just, that one of those atoms is actually sufficient, or one of those atoms is not actually necessary? And I could do it this way. If it's sufficient to express it at the atomic level to disprove the compound, then I've done an atomic operation which disproves the compound, and that's good enough.
Yeah.
Now, in some cases,
I kind of disagree with the premise of disagreeing or not agreeing with the logic of a compound claim, because you're agreeing or disagreeing with the logic for what purpose is really what we're talking about here. Either you're agreeing or disagreeing that the logic in the compound claim matches the language, in other words, matches the string, which is the same issue we have with any other statement in a claim, right? Does that statement apply to that? That's a different thing. Or you're disagreeing with the and, but you can't disagree with the and, because the and is just, it's a definition of the claim.
No,
you may, okay, what you're disagreeing with is, are all these elements necessary for the claim? And the question is, necessary for what? And that means you're putting it into a context, and the context would be as an argument or support for something else. In other words, you're trying to support this other statement with a claim with some ands, and there's an and in there that's totally unnecessary. So in other words, you're disagreeing with the relevance of that claim in supporting some other claim, right? If I say
no. Okay. I think your view is a bit too limited here. What you're saying is not wrong, but I think it's definitely not complete. I can suppose you say A and B and C is necessary to Z, and I'm, even without context, I can say, you know what, your list of necessary conditions is incomplete, I would add D as a necessary precondition. This is not
and
necessarily.
We even as a flashback to the long time ago, we agreed that you can always add claims like that, right? That are necessary.
But you're talking about conjunction as the only case of compounds. And what I'm saying is, suppose that I have more complex compounds, such as, I said the probability of Z is actually A plus 2B plus 3AB, plus C squared, and I could agree that A, B, and C are contributing factors, but have a different formula. This is a case where, or I could say, it's not just this disjunction, it's this actually more complex formula with conjunction and disjunction. So what I'm saying is the disagreeing with the compound is not always as simple as saying, well, it's not just that one being not necessary, and it doesn't always include context.
I disagree with your example.
Fair enough.
Because what your how do I, because your example is trying to be complex. It's hard for me to see where you're trying to use it, but basically what you're saying is the probability of something is X, right? What you're trying to say is the probability of something is X. And then you've got this formula of compound elements that shows that, right? You're playing a word game there, because what you're doing is the claim you're making is the mathematical equation. What you're trying to do is support a result, a claim that the probability of something is whatever, by using a mathematical formula. This mathematical formula shows
the probability
that the probability of something whatever.
Okay.
I mean, it's the same thing as
I'll buy it specifically, but I think my general point stands. Saying not all compounds are disjunction. I spoke about, kind of vector product or max or min as valid ways of composing claims. And yeah, maybe sometimes you can reduce it. You can do the meta trick you just did, which is a valid meta trick, by the way, of saying, what you're saying is asserting the validity of a formula. But I'm not sure that's always the case. I'm saying that saying this will be true if either these or those are true, or if or it's more probable if either of these are true, which is distinct, or it's if all of these are true together, or all of these are true, but maybe not this combination of other preconditions. Like, speaking about combinations is a real thing, and it's not just a mathematical formula. Speaking about synergy is a real phenomenon, not just a mathematical formula. And I'm saying there's a lot of things that can, if it's a conjunction, and I agree, that's a very frequent case, or a disjunction, that's also a very frequent case. It's easy to disprove it at the atomic level. And I'm all for doing that as a special case. And I'm all for saying, let's simplify compound claim argumentation whenever it can be done atomically. And I'm all for that. But I'm saying not all cases reduce to that. And I'm trying to get you to think about more generic compound claim than just disjunction and conjunction. For me, that was starting point.
I think it might be our understanding of what a claim is that causes this, but my belief is that you can define any claim in any mathematical formula. The debate is whether it applies to something else, which means any debate about is this a good construction will happen in the relevance debate of using it for something else. And like, I don't know if we can resolve it except trying to find a counter example.
It's not relevance. It is about is this formula better than this formula, which is a truth question, not a relevance question.
Well, claims are, or if supports are claims, then we're talking about, is it a true thing? It better represents is saying this proves better than the other thing, right? In other words, what is the relevant? To me, that's a relevance thing, right? How true is the support? Is the truth of that support better for that one equation or for the other equation? You're not talking about the results of the equation, which to me is what the claim is. The truth of the claim is, did you calculate that math properly? This claim is wrong because you put in the wrong number for A. Something like that.
Okay, no.
But the fact that,
okay, we don't understand relevance the same way at all here.
I know we've had this.
We're thinking of the most broad way of interpreting relevance right now with the current model, which is the way we had it, right?
Yeah, this is actually worth resolving. There's a disjointness in how we see relevance, and the question of, is the inference true, which is one definition of relevance and one valid one, by the way, let's be clear. I'll come back to that. I want to think how I think of relevance more broadly, but I think that saying, is the inference true? And I'm saying that's a truth claim.
In a different way, how much does this claim support another claim? That to me is the truth, the measure. And when you're talking about, is this a better model or is that a better model? Is this a better formulation or that a better formulation? It's which one supports the conclusion more.
Or which one, oh, that's very different from which one is the most accurate and true one.
Well, accurate and true in what sense? Accurate and true to what?
Well, in the case of where probability can be reduced to a mathematical formula, if I have two different models, causal or differential equation, doesn't matter, right? This is extra, and this is external to what we're doing, and I agree totally, it's external. And I'm saying, this system is represented by these equations. No, it's represented by those equations with different parameter values. That's a truth question. I mean, which of those two models represents your system? And that's external, and that should not be modeled at our level. I agree totally with that. But I'm saying that's a truth question. And when I said there's...
I don't think it's a truth question. Would you say Newtonian physics is a truth question? The world operates according to
Einsteinian versus Newtonian. Yeah, I say that's a truth. Right. I say that's a truth question.
But no, because what are you trying to prove then, right? What do you like?
Is
force equals mass times volume, F equals mv, right?
Well,
that is.
Well, that got,
that's
correct. There's now a correction factor due to relativity. That's exactly the point. It's not exactly true as stated. It's close enough in most cases, but it got refined by relativity. F equals ma. So, and objectively, the one is more true than the other. Absolutely. Einsteinian physics is more accurate than...
yeah, except that... the equation is not wrong. What's wrong is applying it to specific cases of prediction, right?
And more precision is needed, where you're claiming to
be
precise.
Right. You don't say F equals MA is wrong. You're not going to argue it's wrong. You're going to argue it's not appropriate. It doesn't help you in this prediction.
No, but I will argue, is it true that F equals MA corrected by relativistic factor is more true than F equals MA bare? I can say that.
But true for what?
Right.
If it's more true about my computer simulation, or is it true about physics in our real world?
I was speaking about relevant to the real world. And it's true, and it's totally perfectly accurate to say in the context of this calculation or in the context of this whatever.
But but you can
F
make the statement.
MA uncorrected is good enough. That's a perfectly
You can make the
valid
statement F equals MA does not properly calculate something, right?
No,
You can even say F equals MA is
that's something else. That's another statement.
No, you could say, yeah, F equals MA should be applied in fewer situations than the
original
Einsteinian version, right?
Then yes.
And you can hold those debates,
I'm saying,
but at no moment are you defeating the claim F equals MA, which is just really.
I think I am. Yeah. I think I'm not defeating the claim F equals MA is a perfectly applicable solution in this or that particular situation. But as a general claim, I think it got defeated. I'm willing to.
It's not a claim. I mean, is it a claim?
Yeah, there is.
No, the claim F equals MA defines the way the world works.
Yes.
That is.
Yeah, but then it's a definition.
Defeated.
No, it's like, then it's a definition, like defines. What does define mean? Good enough for X purpose? I mean, it all depends on context.
Which is a perfectly valid distant claim, and which I'm perfectly fine with saying is still true. But F equals MA describes the world has got defeated.
No. But now here is a claim. We've been talking about claim as a definition, right? But it's not a definition. But really, F equals MA would be your underlying logic structure, right? And then what you would have is a claim that is something like force is 25 newtons. And then you would have claims, which is mass is 5 kilograms, and A is I forget the whatever.
This is
meters per second, 5 meters per second squared, right? Okay. Yeah. So this is what is a claim. A claim is the force is 25 newtons. And you put in as the logic structuring the claim F equals MA. And then you are putting in as the composites, mass is 5 kilograms and acceleration is 5 meters per second squared. If you can prove those two things, you have automatically proved the claim force is 25 newtons according to this formula. And that is how I see a claim being structured, where if I say Tim and Stephen are members of the CDL, and you prove that Stephen is a member of the CDL and Tim is a member, because if you go to the force one and prove that kilograms, it's only 2 kilograms, right? Then you've disproved that claim with just disproving a single part of that composite. And that is how I see that thing being used, and not arguing about whether the and construct is more valuable than the or construct, because that is when you're trying to use it for something.
Okay, we spoke at length about the relationship between abstract and concrete, or individual and class situations, right? And if you have a specific case or a specific mass and acceleration, and you want to say, hence I deduce that the force is that one, according to the F equals MA definition, with so many significant decimals, blah, 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 it's perfectly valid to use the F equals MA formula, because you've scoped yourself to a situation. And then I will say, yes, it's true until you reach, you apply this force constantly until you reach relativistic speeds. So there's a bound to this, which is another specific claim. So your specific example, which worked in its original bounds, may not apply in a more general bound, but that's even something else. But I'm saying there is also F equal MA, the generic one, also stands as a claim. It's also a claim. It's not because specific claims exist, which is totally true, that general claims are not also claims, which exist, again, in contextual and decontextualized context. And F equals MA decontextualized, I'm saying that's a claim. It's a claim that this applies to the universe in general, and that one got defeated.
That's fine, but you're saying it got defeated as
a decontextualized of, yes.
No,
yes,
it's not decontextualized.
It's not decontextualized. It's in the context of being
a
perfect model of the world. That's the context.
Exactly.
So,
that is the context. It is
okay,
less useful or less accurate model of the world than the other thing. And that is a separate claim which is a valid discussion. And in that case, that claim seems to be on the side of the Einsteinian formulation.
I'm willing to grant you that saying in general about physics is also a context. I will grant you that, but that does mean that it's also true in the decontextualized, it's also falsifies the decontextualized case, because you cannot assert the decontextualized unless it's true in all cases. And I think that means we probably can almost never assert decontextualized claims. I will even go that far. Which is certainly not something you'll be comfortable with.
To me, is context. To me, actually, context in this definition is using it to prove something else. Whereas you can make a standalone statement that F equals MA is less accurate, applies less or models less reality than the Einsteinian, I can't say it, equation. That's a standalone debate. You don't have to say, when I say decontextualize, I'm saying it didn't matter who said it or what book it was in or whatever. It's a standalone claim that you can evaluate and discuss and prove or disprove without knowing where it came from. However, it is a specific claim about these equations and how they apply to something.
This is an interesting definition of contextualized, but I will point out that you've been inconsistent in your use of contextualized, because sometimes you have used it to refer to specific definitions and to specific scope. You have done that, and this is what I was referring to. And so we'll have to be more careful what we mean by context here. When do we mean scope? When do we mean provenance? And when do we mean?
I think personally all of them are context. But I mean, it's a nice example of ambiguity.
Yes.
And if you have an ambiguous formula and you don't say whether you're talking about Newtonian physics or the perfect representation of the world, it depends which one you need, and that fully depends on the context weights. In the conclusion you're targeting.
And I'm saying there is such a thing as some claims pretending to be scopeless, and that's fair enough. It's a scope too, but it's also a scope.
It's ambiguous. It depends. It's undefined. There's nothing wrong with claims. Ambiguous claims can be useful. It's when they start to be used in arguments that you determine whether or not they're too vague or not.
That is fair, and there I do even agree with you. The undefined is a perfectly valid truth value, and there no problem. But on the other hand, there is a moment where we are arguing about generalities, and that is and maybe it does mean that undefined is different from universal.
Take the formula.
I'm happy with that.
Take the formula without any further context. Take the formula with Newtonian physics as context, and take the formula with as context the best representation of the world. These are three different ones. Depending on which context you're looking at, you might agree.
What I'm saying is, if you're arguing for undefined as a valid value, and I'm perfectly willing to agree with that. I think it's a good idea, but I'm also saying general is a valid universal value. You can say, is this true in all cases for any statement, for any general statement?
If the entities are clearly defined.
That's defeasible. That's easily defeasible, right? You come up with one example where it's not true.
Yes.
Is Mark Antoine's table standing in Mark Antoine's room from this specific Mark Antoine? Then
that one is not a generic case, and so it's easier.
I actually had a realization, because we went a bit off topic, even though it was very relevant and interesting. But we started with the whole thing of the compound claim, and I was thinking, if you do model it as a claim, because I guess I'm arguing not to model it as a claim, even though I agree it's a claim, which is a bit. I won't go into that now. If you don't model it in the model as a claim, if you do model it, then what are the supporting and opposing? Are you allowed to add supporting and opposing claims to that compound claim?
You add them to the
components.
Is
interesting, which breaks the Liskov substitution principle, which is a really nice way of saying this is actually not a claim. This cannot be treated the same way as what you're claiming to inherit from.
Oh, that's interesting.
Well, but maybe we have to change the model. Yes, I agree with that. There are aspects that get inherited, and there are aspects that do not. But yes, you are correct. You can't add an argument to a...
Which is a reason not to extend from claim and to model it as something different that points to, like, and I think that's my intuition.
I think though, but here's the thing is, you do want to use it as a premise. You can use it as a premise, which means that either premises aren't claims or there's a higher abstraction that the two share.
Maybe
I think is the right thing.
Maybe let's keep claim as the abstraction, but have atomic claim as a subclass. But I'm not comfortable with that.
Or premise. I guess premise is specifically argument.
No. That's a role. That's not a class. That's a role.
But I would argue a compound claim is more than just a compound claim. For me, entails many claims. It's like the if you have two claims.
But one second. I want you to go over the argument of why compound claim is not a subclass of claim again, because I'm not sure I agree with your premise yet. I understand the substitution, but you said, oh, no, it doesn't. You cannot substitute it in this case. What is this case again? I want to run through it again to be sure I agree with that.
You can't add an argument to a compound claim. You have to add the argument.
What is adding an argument? What is adding the argument?
You don't support or oppose a compound claim. You support or oppose one of its atomic members.
Okay. We don't have support or oppose yet in the model, right?
We do, because you inherit from claim. Yeah. Okay.
Well, I can totally support a compound claim. Yes. So why can't I support or oppose a compound claim?
Give an argument for Tim and Stephen are members of the CDL that isn't specifically targeting Tim as a member of the CDL or Stephen as a member of the CDL.
Fair enough. Let me think about this, because I think it's possible in general. I'm not sure it's possible in this specific case, but I think it's possible in general, because I could be saying, okay,
the CDL doesn't exist.
No. That's a good one. No, but that's acting on both. What I'm saying is it's in the generic case. That's a generic case. But if suppose it's a conjunction and I want to argue it's a disjunction, right? Then I'm doing an argument on the compound.
You're changing the definition of the claim. Yeah, but then you're changing the definition.
Yes, exactly.
Of the claim.
I'm saying the disjunction is not applicable here. I should be using an or. Now in this
applicable for what? Now you're putting it in the context of something you're using it for.
That's
again,
totally true.
Might I interject, because it all points down that you're modeling logic. The thing you try to represent in compound claim, written in claim form, is actually more. If A and B are true, it necessarily follows that C. That's more or less what you're modeling, and we already have proofs, conclusion, and support, by the way, which is also interesting.
But what I'm saying is, even if I were not modeling logic, I can say these two things are not acting. I can contradict the combination that is expressed in the compound claim, and disagree with the specific composition without arguing against the atoms, is what I'm saying.
Then you might as well debate. Yeah.
Let's make an example. Like if Stephen is a member of CDL and Marc-Antoine is a member of the CDL, it necessarily follows that Stephen and Marc-Antoine are members of the CDL. That's what I claim.
You know what? I think you're right. I think
it's modeling logic. It's a claim about logic.
No, it's not about logic, not logic. It's that all these oppositions and supports are about, one second. No, I'm not sure you're right. Okay, I was going to say all these oppositions or support are about the role of this compound in a specific argument. So it's more relevance arguments. So in a way, I'm arguing. But on the other hand, I can say this is jointly true or jointly false. Can I do that without? Okay, suppose I say.
I have an idea.
Go ahead.
How about leaving the whole compound claim, extensor claim out, and modeling formulas or equations instead, and saying the equation itself is a claim in itself, but it just says, okay, claim A and claim B equals claim A and B. And then these are two separate claims where you can agree or disagree with, but the equation in itself.
The equation is not a claim. The
Yeah,
equation,
or whatever.
equation
say,
is a
okay,
logic formula that.
Well,
Yeah.
you can have a claim about the equation.
No, I'm just wanted to say, like, why not?
You can make claims about equations, but the equation is not a claim.
Yeah.
Yes. It's not. The result of an equation is the claim.
No, I agree that you can make claims about equations, and that's a distinct thing. That I'm accepting totally. But is the equation not a claim? I'm processing that.
Yeah, okay, whatever. But in any case, I'm suggesting we can separate equations and claims, and claims are kind of the variables of the equation. That's what we're doing here, because we're saying A and B equals A and B.
They're not the variables that the input. Yeah, they're the input to the variables.
They're doing
claims are the inputs.
I think this is why I keep hinting at. I think it's a second layer. You're doing some. The intent of modeling this is to calculate some output from the input, and in that sense, you're modeling something.
I agree. It's a separate domain of so that. It's a separate domain of so that. Right. I agree with that, but I don't think it can be separated from the model. I think
no, it can be in the model, but then I would argue then it shouldn't probably be a claim in itself. If it's a claim, the claim probably is logical. Yeah, it's like, and that means also you all of a sudden.
The logical connection doesn't have to be in the model, but all the claims, all the elements are in the model. Like the claim A is in the model, the claim B is in the model, the claim A and B is in the model.
Yeah, but then you have them floating around on their own without any.
And then you have this separate layer that connects them.
The equation that connects them. It's the equation.
The equation is still there, but it answers the question: what does it mean to support or oppose this logic? It means that you disagree with the logic. And you cannot say like, oh, yes, because A, yes, because B. No, you're disagreeing with, it's the team is that A, the team is B, the team is C, the ream is everything else. It's the logical component. Do you disagree that this follows from that?
Okay, I'm took a moment to distance myself and think. I don't know if it's layerable or not. It's clear to me that we introduced compound claim as an alternative to multi-premise arguments, and that requirements remains. But what is clear to me more and more is, yes, it makes sense to have a support or oppose a compound claim, because I can totally see situations where I have two different compound claims using the same premise, and I believe the same truth value about the premises, but I don't believe the same compounds equally. For example, if I can believe A is true, B is true, and I will believe both A and B and A or B, but I won't believe A and not B. Those are different compounds, including A and B, and they're disjoint and they're distinct. And that means I can have support of or I can have support of A or of A and B independently of the fact that I support A and I support B. I can say, okay, or sorry, let me rephrase. Suppose I have A, B, I think they're both true. A and B is claimed and A or B is claimed. I think A and B models the world because A and B are, no, that's not a real case. Damn it, I had a real case and I lost it.
I think you can't. I think you're confusing. Is this claim useful?
Yeah. I did at some point and I didn't at some point. So I think I had it.
I do have one thing I can argue in favor of debating, the formula. which is contrary to what I think at the moment is contrary to what I think should be done. But here's the argument in favor of arguing the formula used in a claim. It's the same argument in favor of parameterization of a claim, which is you cut down the number of duplicate arguments, essentially, which is in the case we have force is 25, right? And you have using F equals MA as a thing. And then you have another, what's the easiest way to formulate this? Yeah, I'm gonna have to come up with the example that I had before. But basically, it's one of those cases where an argument in support of one is an argument against another, and that is a duplication. So, any argument that using Newtonian physics is worse in this case than using Einsteinian, any argument in favor of using one is going to be an argument against using the other. And that is something that we've sought to reduce in general through structures and model, right? Like here, if it were, if the claim is that at least two of us are members of the CDL, right? And then you make a claim, Tim and Stephen and Tim's daughter are members of the CDL. And you make a second claim to support that. And you make a second claim, Tim and Stephen are members of the CDL to support it, right? The first example is wrong logically, because, or it's false logically. You have invalidated that Tim's daughter is a member of the CDL, and therefore that compound claim is false. But it doesn't disprove anything, because you say that you argue that is an improper formulation, and you argue the other is a proper formulation. And you sort of duplicated arguments about relevance. It's not the cleanest example I wanted, but there are cases where you essentially have to debate against multiple supports. And the debate against multiple supports, it's which support is the most appropriate. I don't know. I think in that simple example, going with compound claims will work, but I don't know.
I'm afraid I had trouble following, but I have an independent question for Stephen. When you say you cannot support a compound claim, I'm trying to think, what is it you're not allowing? Because it's clear to me that a claim can be used as a compound can be used as a premise, and a compound can be used as a conclusion. So what is it that's not allowed?
It depends what a compound claim is.
It's not used as a conclusion.
Oh, interesting.
Used as a conclusion.
There was a question from me.
It's derived as a conclusion. Its truth is derived based on using others as conclusions.
But anyway, it can be used as a premise, and for sure. Go on, Stephen.
It depends on what a compound claim is. If you write the claim out in full and it's true or false, what does it mean for it to be true or false? Because I can just as well argue if a compound claim, why not just add, if a compound claim as components A and B, why not just add as supporting A separately and B separately? Because A supports A and B supports A and B. Why is that wrong, for example, or that isn't wrong? So it all depends.
Because B doesn't support A and B. If B doesn't support, it's the Stephen and Donald Trump example. The Stephen and Donald Trump example, right? You prove it by proving Stephen is a member of the CDL and Donald Trump is a member of the CDL. But you're talking about the second one.
Again, talking about logic, but if you look at like how we have been adding, basically, if you're saying that is what a compound claim is, then we also need to rethink what current support is and what current relevance is. They
That-
kind of go hand
yes.
in hand. You cannot say that a compound claim is this without then changing the meaning of what support is.
Fair.
Yeah, you can. You change that you can't support a compound claim. It all works if you just don't support compound claims.
Did you guys look into what I wrote in the chat?
Yeah, the A, B, C.
Yeah. Because they are presented these 3 claims independently. You can agree or disagree, agree or support each of those, and they're only connected by equation that's separate.
Right.
That's what I meant.
Yeah, and I'm also thinking more along those lines, and then you can still represent it in a base model where A and B in this example does support C if you want to represent it as such. It really.
But the problem is that it's not defeasible, right? You can't. You defeat one of them. You haven't.
But it's
impacted
not,
claim C. You haven't impacted the result.
It keeps coming down to what what do you want to do with
Yes.
scoring? I have no intent whatsoever on automatically calculating score. The entire model that I want to create has to do with allowing the user to easily navigate to the discussions that are relevant to focused. It is defeasible from a user perspective. The user can see, well, I don't agree with C because A is wrong. And the user interface will allow to say, well, 90% of the people that don't believe in C, don't believe in it, also don't believe that A is true, like Donald Trump or whoever. That for me is much more important than automatically saying, oh, well, the calculation basically.
Yeah, I'm not saying that the equation needs to be calculated by the computer. It's just like that we represent it structurally and people can follow it, as you said. Yeah.
No, I agree with, we can model the equation, but I'm saying, I think it's a separate model that sits on top of merely connecting pieces of information.
No, okay.
Yeah.
No. But what I'm saying here is that this is not the way you'd have to formulate it in without using the logic structure.
Mhm.
Is you would require 4 supports in this case. You need a cross product. You need Tim is a member of the CDL and Tim is not a member of the CDL. Stephen is a member of the CDL and Tim is not.
But will somebody,
or rather, Tim is a member of the CDL, not Tim is a member of the CDL, right?
if you want to model the logic,
and
will somebody argue Tim is not a member of the CDL? If they do, yeah, add it.
Yes.
But you're talking about modeling logic, but that won't come up. If somebody writes Tim and Donald Trump are members of the CDL, then somebody will say, no, that's not true because Donald Trump is not a member of the CDL. That works. It supports the use cases. It's more like.
Okay, I see what you're saying, Stephen. I see the point. I mean, of course, I'm, as usual, want to model more than you. That's one thing. But what I'm saying is, I think there is definitely a generic so that we want to at least connect A, B, and C.
Yeah. Yes, but I would do that separate from. I would.
But what I'm saying is, once you're connecting them, why not allow logic? Because there's not that much difference in work in connecting them with and connecting them without logic. It's doing the logic on top of the fact that you already have a connection. For me, that's duplication of work, because not connecting them, I think, is not viable. Connecting them without logic and then having a separate equation, I think, is duplication of work.
So first of all, I'm not against modeling the logic.
Yeah.
It's more like where do you model it? That's my whole discussion. I'm not against modeling the logic, but I'm very uncomfortable with modeling it as a claim because it makes it super ambiguous how to model it in the current model. And the more difficult it is and the less uniform, clear is where to put things, the more disagreements, the harder curation and canonicality is going to be. That's my concern.
I'm beginning to buy into the argument that compounds being claims may be a problem. But then if compounds are not claimed, it almost forces us to have the equation, because if we model the composition without the equation and people only speak about atoms, truth or falsehood or support or support oppose, then we'll have to use, how will we know how the support oppose on the atoms is used in a specific argument where we've introduced a compound because we need a compound for multi-premise? How do we know how that support of the atom translates into support of the argument in which the compound is involved without the equation?
I mean, as was already raised, I don't know by who, maybe we have to ask ourselves if supporting also is kind of an equation or something sitting on top, because then it can be more connected to equation stuff in general.
What I'm saying is, I could accept the notion you only supported the notion of at the level of atoms. Okay, fair. But then when I have a compound, because we know we need a compound for multi-premise, when I have a compound as a premise, and all I've done is support or opposed atoms, how do I know whether I've supported or opposed the argument? I need the equation. So you've made the equation basic. If you're saying the only thing you can oppose, and maybe you're right. Maybe that's just the proof that we need equation. We need equation so that we know how oppose support of atoms translates into support of oppose of the multi-premise arguments. Because we have to translate from one to the other. We cannot not do that.
I'm almost leaning back the other way again, where I'm kind of convinced by Stephen that you know, maybe we don't need, maybe it's doable without other formalisms, but
we're just basically just leaving out the equation from my example.
Well, here's the thing: is if an equation is a definition, right? We've said that F equals ma is a definition, right?
No, not that kind of equation.
You're not going to debate. No. This is okay. I'm pointing it to the example that we might want, right? And I said, well, okay, the claim is that force is 25 newtons, right? And you embed in it F equals ma as the logic part of a compound claim, and then the atoms are force is mass is 5 kilograms and acceleration is 5 meters per second squared. Okay, you debate then if that's actually the mass, and you debate if that's actually the acceleration, and having that done, it's a foregone conclusion that it's true that it's 25 newtons. Okay, is there another structure that would do it in just the simple version that we have here, right? In that case, maybe the claim is, according to F equals ma, force is 25 newtons. That actually works, because what you're doing is your definition, you know, F equals ma. According to Newton's equation for force, the force is 25 newtons. And then you have in disambiguation or whatever, a reference to Newton's F equals ma. And then you can debate about whether or not that's true. And the debate would be, well, you know, for mass is only 4 kilograms or something.
That would be another way of modeling it. And yeah, you don't model the logic. It's up to the users using the model to add that, but you can represent the conversation with the base model, which is somewhat the point.
What I'm saying is, if you don't have equations and you just have opaque compounds which cannot be opposed or supported, and you don't have equations to see how the oppose of atoms gets combined in the compound, what you have is F equals ma. I'm saying F equals ma would yield 25 in this case, and I have mass equals 5 and acceleration equals 10. Oh, well, mass equals 5, so this supports, so that's good enough, because I don't know if it's a conjunction or a disjunction.
But Stephen's point is good, which is that if nobody opposes that in any way, then it's fine. It is fine. If somebody wants to oppose one of those facts, that's part of it. It becomes part of the debate and would have an impact. But if it's just something that people can take as a foregone conclusion, okay, humans are good with that result. The thing that I remember way back the first time I was thinking about multi-premise claims and these and relationships and everything is like, what's the difference between, and which is what a compound claim is essentially. How I designed it was as a compound claim. You know, what is the difference between modeling two separate support arguments versus having it embedded as logic? The difference essentially is you've removed the discussion over the relevance of that. Because if the relevance discussion or debate is replaced by the equation, so you're only debating whether or not it's true that it's 5 kilograms, that mass is 5 kilograms, and you're not debating how important that fact is because it's embedded in the equation. That's what replacing with an equation does. It removes the discussion about the relevance of that fact.
Or moves it to if an equation is a claim, to a discussion of that.
Well, then you
equation.
discuss, then you're discussing about if it's the right equation, which I think should also probably be moved out, but whatever. Yeah. It's the same realm of, you know, are we using the right definition or whatever?
Well, I'm very sorry. It seems like I set us back an entire meeting with what I introduced as a simple concern.
It was quick.
No. It's, I think this is a useful conversation. I'm not, and thank you for bringing out some very important questions as far as I'm concerned. I don't have a final.
Yeah, neither do I.
But I'm certainly more and more seeing at some point we'll support and oppose atoms, and we want to know what that means for the compound in a specific argument. Where I had to change my mind is I was thinking of it was meaningful to debate the compound claim, and now I'm doubting that more and more. So maybe you're right that compound claim is not a claim, but it's also still a premise, and we do want to know how to translate from, and there I'm totally behind you. Sometimes we'll want to do the debate at the atomic claim level rather than debating each compound individually. And so for that reason, we need to know how the atoms combine in the compound.
Let me rephrase what I said by I don't think compound claim is a claim. I meant that the reason both of you seem to want to introduce compound claim has more to do with modeling the logic than actually representing a compound claim in the same way that we currently had claim and support. My understanding of it being a compound claim, I would be totally fine with if you have a compound claim A and B, then I would just say, well, A supports A and B supports A and B in the same framework. But that's not the reason why you're modeling this. That's why you were like reluctant to say that you can support and oppose a compound claim, because what you're actually trying to model is if A and B, then it necessarily follows that C. That's what you're trying to model. And if that's what you're trying to model, why don't we model that instead?
Well, well, this is exactly why we introduced compound claims, right? It's to model multi-premise arguments. Yeah, but
it's different, because this as a claim, if A and B, it necessarily follows, and C, you could also consider as a claim, but it doesn't support C. This whole thing.
Yeah. And the whole question is what is the relationship between A and B support C and A and B, which are as independent claims, because we do want to be able to reduce that arguing about A and B support C to arguments about A and arguments about B.
Yeah, but so I'm inclined to say that's why I think it's a separate level, and it can be in the same domain. But if we have like A supports C and B supports C with our current model, and in addition to that, we have a parallel description that says if A and B necessarily follows that C, which is also a claim, which of course, because it references C as a conclusion, you also have that information.
But what I'm saying is you also have A or B supports C, and that's a
Yeah.
separate compound claim. And then the question is, that means that the defeating A has distinct impacts on different compound claims. And I understand we could do things by hand, but I think modeling how the impact is different is useful to the user. Because otherwise you have to do a lot of operations to say, okay, what's the impact on this combination formula? What's the impact on this combination formula? What's the impact on this combination formula? And this is also prohibitive, and this is also an obstacle.
What do you mean by impacts?
What I'm saying is, okay, I have 20 compound claims that involve the atom A.
And when you say compound claim, which is it
Or
like
20,
a logical
20, okay,
function?
sorry, 20 multi-premise arguments that involve A as part of the premise. Now I defeat A. What is the impact on those each of those multi-premise arguments? It depends. And I'd like to not have the user
By impact,
revisit
you mean
each.
how true or false the conclusion is, or
Did it actually, does defeating A actually defeat the the various formulas involving A and in arguments, in specific arguments? I've moved back on that one, but yes. And I'd like the user to not have to revisit the 20 of them to say, okay, well, defeating A actually, oh, this one's still fine because that was an OR, and this one's not fine because it was an AND. And
yeah,
this
so
one,
but then you expect the user to agree with the formula, and if the user agrees with the formula, it means that you automatically can infer whether or not the user
yes, that's
agrees
what
with
I'm
the
saying.
conclusion. But that's again, that's
and I'm saying that ultimately saves time for the user.
Yes,
that's what I'm saying.
It does, but I just wouldn't call it a compound claim. I would call it a formula or something like that. And indeed,
Yeah.
formulas can use claims. And if a formula, then if you know a user agrees with A, a user agrees with B, a user agrees with the formula, yes, you can tell the user yes. I mean, it logically follows you believe in C.
Yeah.
But I see that as a separate thing. It stands separate from this claim structure we have.
Listen, I see what you're saying about it being a separate thing, but I'm saying I think we've shown that it's a core use case.
Yeah,
as
but
far as I'm concerned.
Again, I'm not disagreeing with the use case. I'm disagreeing with the compound claim extending from claim here and the
core
way you
use
want
case.
to use it.
Core use case. I don't see the point of putting it in a separate UML diagram. Is what I'm saying.
I'm okay with it being in this UML diagram. That's okay.
Okay, I think folks, it's 20 past the hour. Are you okay with closing? I have crazy things to do today.
Yeah, we got a lot to do too.
Yep.
A lot of thinking about this.
Yes. No, so thank you for that. That was useful.
Yeah, very helpful discussion. Stephen, you can give us more quick comments tomorrow.
I think this was my only comment. It took the entire meeting. Sorry for that. See you tomorrow.
See you tomorrow.
See you tomorrow.